Raul could not make it, so I'm winging it. So industrial control systems are devices and systems that run this world. Did everyone notice how the... Oh, come closer. Oh, sorry. Did everyone notice the elevator system in this hotel? It's an interesting concept, right? A little bit scary too, if you ask me, but industrial control systems are found everywhere. ICS runs manufacturing or keeps electricity flowing or the natural gas flowing through the pipelines by controlling the pressure, or systems that run oil refineries, or the computers that runs your automobiles. They're very pervasive. The system can be a server with resources such as full operating system, powerful processor, large amount of memory, and sufficient disk space to systems with microcontroller processors, real-time operating systems, smaller amounts of memory, and no disk drive. Microcontrollers, processors, flash memory, and even smaller amounts of dynamic memory, depending on, oops, sorry. I have so many notes I have to scroll. Depending on these factors will determine what kind of cyber threats or cyber threat hunting can be performed. Cyber attacks can be penetrating on any of these kinds of systems and devices in various ways. These are examples of some industrial control systems that you see on the screen. ICS is not so much about data being generated than it is about controlling functions and facilitating processes. It's very unlike an IT system. There can be a subtle difference between whether an industrial function is failing due to some physical failure or a cyber attack. Cyber threat hunting is so important in an industrial control environment. Life safety is most important in industrial environments. People and the environment can be harmed if a cyber attack causes havoc. Secondly, availability is foremost in the industrial environments. If production comes to a halt due to some cyber attack and other kinds of events, then a financial impact on the company can occur. Thirdly, integrity of a formula or a process is very important. For example, if a cyber attack affects a process and changes the formula of a chemical product or a pharmacological product, there are wide-ranging ramifications. Confidentiality mostly comes into play within an industrial environment. If a process or formula or network diagrams are exposed, which may contain information about a process or a formula in the coding of the system or device. ICS uses specialized TCP/IP protocols that you don't find in IT business systems. For example, application layer protocol Modbus, which I'm going to talk a little bit about in a few slides. Modbus TCP has special function codes that are used to control the functionality of an ICS device and can even shut down a device. Imagine if a cyber attacker was able to force an industrial control device offline, like these elevators in this hotel. Not to pick on this hotel, because it's pretty rampant, these kinds of systems. Cyber threat hunting is about detecting the unseen and the undetected. The primary objective is to intercept potential attacks before damage is done or to mitigate damage of an attack in progress. Cyber threat hunting should be proactive. Otherwise, if malicious activity is seen and apparent, then it should be handled by the incident handling process. Many organizations lack the advanced detection capabilities needed to stop the advanced persistent threats from remaining in the network, especially in ICS networks. Cyber threat hunting digs deep to find threat actors in your networks and systems that have slipped past your initial endpoint security defenses. Firewalls are a sieve in an industrial control environment and in IT environments. So this is the process. I did not come up with this process. It was developed back in 2012 by a company called Squirrel, which I think one of the big cloud companies got. It might have been even AWS. I think Amazon bought them back in 2012. Cyber threat hunting instances should have a time limit on it. You should not do it forever. Move on to the next threat hunt if you don't find any evidence after a certain set amount of time of doing threat hunting. Once one hit hits the time limit, whether your hypothesis is proven or not, move on to the next hunt. The hypothesis is the most important part of the cyber threat hunting, because if you don't have a good hypothesis, you're probably not on the right path. I have a slide on the hypothesis that gives you some ideas, but can be based on a malicious cyber attack reported, or some cyber intelligence, or an educated hunch. The purpose of the cyber threat hunt is to prove or disprove the hypothesis. The next step in the process is to investigate with tools such as SuriCata and other tools and various hunting techniques. If the hypothesis is proven, new patterns are discovered, tactics are discovered, techniques are discovered, and procedures. They should be used to enrich the analytics. This is a cyclical process. Use what you find in your cyber threat hunt for the next time. Once hypothesis is proven, then information gained from the process should be immediately turned over to the incident response process for mitigation. Cyber threat hunting is not intended to be a mitigation process. Sometimes it's the same team depending on the organizational structure. If it's a smaller company, it's typically the same team. Cyber threat hunting, I already mentioned that, it's cyclical. What is learned from the cyber threat hunt should be used to improve the environment, hopefully to prevent some types of future attacks. Right, so there are three kinds of cyber threat hunting, in my estimation, in my experience. There's structured, which is aligned and based on the TTPs of the threat actors. So MITRE framework, and I have some slides on MITRE framework. I'm going to run you through a MITRE framework scenario. This type is using the MITRE knowledge base, as I call it. The unstructured hunt is more aligned to intelligence gathering or intelligence-based hunting, where the trigger could be any of the IOCs, the indicators of compromise, that's out in the intelligence databases. This often is the cue for a hunter to start looking for pre- and post-detection patterns. The hunter can research as far back as the data retention and previously associated offenses occur or were allowed. The hunter's approach is based on this research. A hybrid hunt is a combination of the two. So, These are some of the types of hypotheses that you could think about when coming up with a hypothesis. It could be a driven investigation. Knowledge of a threat is a source through a large pool of attack data, given insights into attackers' latest techniques and procedures, the TTPs, or similar TTPs. A new behavior is a variance of baseline. A good example is a system is acting sluggish or slow, especially in an industrial environment. In an industrial control system environment, speed of a process is very concerning from an availability standpoint. Examples are Bitcoin mining software found in a manufacturing environment causing a system to be sluggish. We did this exactly. We were called into a manufacturing firm and we found several HMIs and other systems in their network from a complaint they made. That was our hypothesis made from their complaint. They were sluggish, and we found Bitcoin mining on several systems. And they immediately their IT department immediately went to work. They went off to incident handling. They immediately went and used standalone anti-malware software on many of those systems to clear those systems up, and the speed came back up on those systems. In an industrial control system environment, system results standing out from ordinary can be very concerning from an integrity standpoint. Example, this type of attack could ruin a chemical batch in a chemical manufacturing process. Another example is natural gas has to be mixed with certain amounts of air to reach a proper BTU, British thermal unit, level. Otherwise, the natural gas could burn too hot. And it's often called burning the beans because there have been examples of where the natural gas in a food manufacturing facility was too hot and it did burn the food as they were cooking it. So I have an example here of one of our test environments. What you're seeing is, you can read it, but what you're seeing is on the right-hand side, there is a PLC, a programmable logic controller, with a NIC card in it, going to happens to be a Netgear switch that has port spanning in it, or port, I'm drawing a blank. It has a span port in it. And the little box on top of it is a Raspberry Pi 4 with 8 gigs of RAM. And we have it plugged in, it's 1 gig port plugged into the span port of the switch. And then we're using a USB 3 NIC adapter, network adapter, which is going back to a SIM and various other things within this test environment. And it does a fairly good job in a small environment. And you also have to keep in mind, these could be good sensors in some industrial control environments because they are the Raspberry Pi today is very powerful. And in many cases, the speed of those networks are not even a full gig. Some of them are still 10/100, so this would work fine in that environment. Larger environments, and in the SCADA data center, I wouldn't recommend this. I would recommend a full-size appliance with enough cores in it to handle a more IT-type network within a SCADA environment. So here's an example. So MITRE has several. If you're not aware of it, they have several knowledge bases now, or frameworks, and they happen to have one with ICS types of TTPs and various things like that. So this is an example of that. I know it's an eye chart, but I'm going to show you here where we're depicting a scenario. It starts out, so we're running a cyber threat hunt looking for the following activities. So our hypothesis in this case is based on a malicious actor gaining access to an engineering workstation. So an engineering workstation, if you're not aware of that, isn't a PC or probably a little bit more powerful PC, and it can contain programming information for ICS devices in it. It's generally used for that purpose, and it can contain a whole slew of vital information. Even on the confidentiality side, it may have information about processes and various other aspects of that. So if a hacker, or what I call a malicious actor, gets a hold of an engineering workstation, it could be a very good jumping off point for them to get to other things. And in this case, what we're depicting here is the malicious actor changes the operating mode from that engineering workstations of an ICS controller, like the PLC I showed you earlier, to program mode. So they've changed the operating mode from probably run or stop to program mode. The malicious actor then downloads a modified program to the target ICS controller. At that point, the malicious actor goes back and changes the operating mode back to run mode, and whatever malicious code they put on that, or maybe even change the process on that device, is now in run mode, and the malicious actor has now manipulated the controls on that target ICS controller. And from the MITRE attack, they could do all kinds of things. That's just one scenario. They could actually stop it. They could do loads of things to that device, and they could get into other engineering workstations as well. So this is just a short scenario to show you what could happen. But SuriCata has signatures, or you can create custom signatures to see this kind of activity. And you'll see in a minute some more of that. And other functions within SuriCata could be used to detect things that were not stopped by a firewall or some other kind of security measure or control. So one of the areas that SuriCata and other tools could be helpful in is many of these devices, these ICS controllers, as I mentioned earlier, do not have resources to run a regular operating system. And so some of the times, you can't even put a security agent on some of these devices from other tools, like CrowdStrike or anything like that. They can't get on those tools because there's no memory or no disk drive to store it. And so you have to start looking at the network activities. So you want to check for persistent connections is one of the ways. Check to see if any industrial control systems are in constant communications with unknown hosts on the internet and even on the internal network. I have to mention this on the internet because there is Internet of Things. All this activity, all this cyber threat hunting can work for IoT as well as industrial Internet of Things. And it's kind of a misnomer because sometimes within an environment, you have those same kinds of devices. And it's not necessarily on the internet, even though that term is in that acronym. Camera systems inside of manufacturing firms could tell the attacker a lot about activities inside there. And if they're on the internet or somehow they got into the environment and they're not on the internet but got in the environment, you need to find them. And you're going to be able to use tools like SuriCata to find network activities. And as we improve SuriCata and get more things around it, which I'm going to talk about in a little bit here, it becomes even more powerful tool in the industrial control environment. We want to see if any of the internal systems are in constant communications with an unknown host on the internet or even an internal network, as I mentioned before. These connections could be indicative of an active C2 channel, a command and control channel. The frequency of communications is an important factor. Timing consistency could be indicative of a C2 connection, commonly called beaconing. Analyze the communications based on the amount of data being transmitted each time the IoT device or the IIoT device or the industrial control system device connects to an external host. And that could even be inside the network. So there could be a C2 channel on another device, a SCADA system where they've infected more of an IT type system. We used to think that these environments were safe, and they were safe in the olden days when it was all physical controls. You couldn't get to them because they were in locked cabinets. Today, in many environments, they're wide open, and they can be exposed to phishing and other kinds of malware activities. So we have to look at both systems and look at network traffic to be able to find some of these in our hunts. Try to identify all compromised devices while you're doing your hunt, because of what I just said, there could be other devices in the network that only talk to these industrial control systems periodically. So you need to be in constant contact with them. And again, I said, put a time limit on your host, on your hunt. If you don't see something after your period of time that you've set as part of your process, move on. So here's an example of some data, and you can read it there, but the network pattern is most likely associated with beaconing, but you must dig deeper to find out where it's coming from. So in this case, it's this consistency across that whole diagram. And it's a 24-hour period, and there were a number of connections that took place over 15 minutes. And along with that, it comes this example of, in this case, the example shows the number of connections transferring amounts of data. In this case, approximately 42,000 connections transferred 52 bytes of data over a 24-hour period. So small amount of data, but a large amount of connections. Analyzing the communications based on the amount of data being transmitted each time a system connects to another host is important. Consistency, again, and session size can be indicative of a C2 activity. And I'm just pointing out one kind of activity, C2. It could be any numerous kinds of activity. You would probably see if they were not beaconing but actually taking data out, you would see a different pattern. So this one shows, this is where I'm going to get into some detail on some protocols, industrial control protocols. Modbus TCP is the oldest. Well, Modbus used to be serial, and it still is in some cases, but they were able to come up with a TCP way of doing it, a network way of doing it. But it's one of the, if not the oldest, it is one of the oldest industrial protocols out there. It was originally designed to be used for programming PLCs, and it was used on the original PLC from a company called Modicon. Part of the name came from Modbus. And what this chart is showing you is the different kinds of function codes. It's an application layer protocol in TCP, but it has function codes. Even in the serial day, it had function codes. It still has function codes. And some of these function codes can be used by the malicious actors to do terrible things to environments. You can shut off systems using these function codes. You can make them, in my scenario I showed earlier, the MITRE, if it was a Modbus situation, that's how they were able to do that right, because they changed the function code to say, I'm in the programming mode, I'm in the run mode, and then on top of that, you can write to the buffers of that PLC, so the memory space. If a malicious actor gained access to a Modbus server or a Modbus client, they could cause the device to not function in the manner it was intended, as I just stated. And there are so many of these protocols that are like this. The one I'm going to show you next. I'm going to show you some PCAPs too to actually illustrate this. So here is DMP3. It's used in mostly in the electric industry. It not only has request and response codes. It also has internal indicator codes, so like error codes. I'm going to move on. We got 4 minutes left. If we have time at the end, I'll show you these demos, because these demos might take a little bit of time. And yeah, that's why I'm going ahead. If someone wants to come visit me, I can show you the demos afterwards or on break or whatever. But anyway, I'm not going to spend a lot of time on these slides, but the keywords, these keywords are in SuriCata today. You can use these in signatures. And I'm not going to go through the slide, but they're available. DMP3 is available in SuriCata today to be used for your hunt or protecting your ICS network. And then there are two other ones I'm not going into great detail. One of them typically is not in industrial control, that's MQTT, but it's used in a lot of PLCs today for data transfer and various other functions. And then SuriCata also has Ethernet IP, which is part of SIP. And I'm not going to go in great detail on these keywords, but I'm putting a plug in that BACnet IP is a UDP protocol, application layer protocol that is used in a lot of building automation systems. The malicious actors can do a lot of nasty things to building systems. I wouldn't even be surprised if these elevators are not on BACnet. And then Siemens has a proprietary but very common protocol called Siemens S7COM they use in their PLCs. It also has commands. BACnet has commands. Signatures can be developed around these, or keywords. So it's a little bit of a plug. And then there's also OPC UA. This is the new OPC, not the old one that was out before that had all kinds of problems. This is used a lot for machine-to-machine communications. And I have 2 minutes left if anyone has any questions. This is my detail about my who am I, my contact information. So if anybody has any questions, and certainly come visit me afterwards or this evening. I'll talk all day long on industrial control systems. It's my topic.